When preparing to wire a new home, a key decision is where to purchase electrical supplies. Two common options are Home Depot and electrical contractors, each offering distinct advantages and disadvantages. Home Depot provides the convenience of a readily accessible location and a large selection of supplies. The pricing can be competitive on some items and self-service is available. However, Home Depot may not stock all specialized equipment or parts, and the availability of knowledgeable staff for in-depth assistance may be limited. Electrical contractors, on the other hand, offer access to a wider range of supplies, including specialized equipment that Home Depot might not carry. They can provide expert guidance and technical support, which can be invaluable, especially for complex projects. Bulk discounts are often available through contractors, potentially saving money on larger projects, but their prices may be higher than Home Depot's on individual items, and self-service options are generally limited. For basic wiring supplies such as wire, conduits, and switches, Home Depot can be a convenient and affordable choice. If the project involves specialized equipment, requires bulk supplies, or necessitates technical assistance, purchasing from an electrical contractor is likely more beneficial. When undertaking major electrical projects, such as rewiring a home or installing a new electrical system, consulting an electrical contractor is highly recommended. For complex wiring needs like installing high-voltage equipment or industrial controls, an electrical contractor's expertise is essential. Home Depot staff can be helpful for basic wiring projects such as adding outlets or light fixtures, and for smaller supply purchases where general advice is sufficient. When choosing between these options, comparing prices is crucial. Consider the type of project and your own level of experience. If there is any uncertainty about any aspect of the electrical work, seeking professional guidance is always advisable. Always follow electrical codes and safety precautions to ensure a safe and compliant installation. For example, when running non-metallic sheet cable, often referred to as NM cable or Romex, through bored holes and wood studs, the National Electrical Code, NEC, specifies requirements to protect the cable from nails and screws. NEC Section 300.4 D addresses this, requiring that if the edge of the bored hole is less than 1.25 inches from the nearest edge of the wood member, the cable must be protected by a steel plate or bushing. This protects the cable from penetration by fasteners. When working with electrical panels, understanding the overcurrent protection requirements is vital. Circuit breakers and fuses protect conductors from overloads and short circuits. The NEC dictates the appropriate size of overcurrent protection based on the ampacity of the conductors. For example, a 15 amp circuit typically uses 14 American wire gauge (AUG) copper wire protected by a 15 amp circuit breaker. A 20 amp circuit typically uses 12 AWG copper wire protected by a 20 amp circuit breaker. It's crucial to adhere to these guidelines to prevent overheating and potential fires. Grounding is another critical aspect of electrical work. The grounding system provides a path for fault current to return to the source, allowing the overcurrent protection device to trip and clear the fault. Grounding electrodes, such as ground rods or metal water pipes, must be properly installed and connected to the electrical system. The size of the grounding electrode conductor is determined by the size of the service entrance conductors, as outlined in NEC Table 250.66. Improper grounding can lead to dangerous electrical shocks and equipment damage. When installing receptacles, it's important to use the correct type for the application. Standard 15 amp and 20 amp receptacles are used for general purpose circuits. Ground fault circuit interrupter (GFCI) receptacles are required in damp or wet locations such as bathrooms, kitchens, and outdoor areas. GFCI receptacles protect against ground faults, which can cause severe electrical shocks. Arc fault circuit interrupter (AFSI) breakers are designed to protect against arc faults, which can cause fires. The NEC requires AFSI protection in many areas of the home, including bedrooms, living rooms, and dining rooms. Using the correct type of receptacle and breaker is essential for safety. When running conduit, it's important to follow the fill requirements specified in the NEC. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. Exceeding the maximum fill percentage can make it difficult to pull wires through the conduit and can also lead to overheating. NEC Chapter 9, Table 1 provides the maximum conduit fill percentages for different types of conduit. When making wire connections, it's important to use the correct type of connector for the application. Wire connectors, such as wire nuts and crimp connectors, must be listed for the size and type of conductors being joined. Improperly made connections can lead to loose connections, overheating, and potential fires. Always follow the manufacturer's instructions when making wire connections. When working with electrical equipment, it's important to understand the voltage and amperage ratings. Voltage is the electrical potential difference between 2 points, measured in volts. Amperage is the measure of electrical current, measured in amps. Electrical equipment is designed to operate at specific voltage and amperage ratings. Exceeding these ratings can damage the equipment and create a safety hazard. Always check the equipment's nameplate for the voltage and amperage ratings before connecting it to the electrical system. When installing lighting fixtures, it's important to consider the type of lamp being used. Incandescent lamps, fluorescent lamps, and light-emitting diode, LED, lamps all have different characteristics. LED lamps are more energy efficient than incandescent and fluorescent lamps and have a longer lifespan. However, LED lamps may require a different type of dimmer switch than incandescent lamps. Always check the lamp manufacturer's specifications before installing a lighting fixture. When working with three-way switches, it's important to understand how they function. Three-way switches allow you to control a light fixture from 2 different locations. The wiring for three-way switches can be complex, but it's important to follow the correct wiring diagram to ensure that the switches function properly. The NEC provides detailed information on the wiring of three-way switches. When installing smoke detectors, it's important to follow the manufacturer's instructions and the requirements of the local building code. Smoke detectors should be installed on every level of the home and in each sleeping area. Smoke detectors can be either battery-operated or hardwired. Hardwired smoke detectors should be interconnected so that if one detector alarms, all of the detectors will alarm. When working with electrical panels, it's important to maintain a safe working distance. The NEC requires a minimum working clearance of 3 feet in front of electrical panels. This clearance allows electricians to safely work on the panel without being obstructed. The working space must also be kept clear of obstructions. When installing electrical equipment outdoors, it's important to use equipment that is rated for outdoor use. Outdoor electrical equipment is designed to withstand the elements such as rain, snow, and sunlight. Outdoor receptacles, lighting fixtures, and panels must be weather-resistant or weatherproof. When working with underground wiring, it's important to follow the NEC requirements for burial depth. The burial depth depends on the voltage of the wiring and the type of location. For example, direct burial cable for a 120-volt circuit typically requires a burial depth of at least 12 inches. Conduit containing electrical wiring typically requires a deeper burial depth. Always check the NEC for the specific burial depth requirements for the situation. When working with low-voltage wiring, such as telephone wiring or data wiring, it's important to keep it separate from high-voltage wiring. Low-voltage wiring should be run in separate conduit or cable trays. This prevents interference and potential damage to the low-voltage wiring. When installing a generator, it's important to follow the NEC requirements for generator installations. A transfer switch is required to isolate the generator from the utility power. This prevents backfeeding, which can be dangerous to utility workers. The generator must also be properly grounded. When working with solar panels, it's important to follow the NEC requirements for solar panel installations. Solar panels generate direct current, DC, electricity. An inverter is required to convert the DC electricity to alternating current, AC, electricity. The solar panels and inverter must be properly grounded. When installing electric vehicle EV charging stations, it's important to follow the NEC requirements for EV charging station installations. EV charging stations require a dedicated circuit and a ground fault circuit interrupter (GFCI) protection. The charging station must be properly grounded. When performing any electrical work, it's important to use the correct tools for the job. The electrical tool should be insulated and in good condition. Never use damaged or defective tools. Always wear safety glasses and gloves when working with electrical equipment. Before starting any electrical work, always turn off the power to the circuit at the circuit breaker. Verify that the power is off using a voltage tester. Never work for live electrical circuits. If any doubts exist about the safety or complexity of an electrical task, consult a licensed electrician. Electricity is dangerous and mistakes can be fatal. First and foremost, always prioritize safety.